You're listening to Nats FM, the home of distributed systems chat.
Nats FM is brought to you by Synadia, the stewards of the Nats project.
Hey folks, welcome to Nats FM. This is episode 9, and for episode 9, I think we're going to rewind from some of the topics we've been talking about recently to something more fundamental to what we can do with Nats. So before we jump into that, let's just have a catch up, I guess. Byron, how are you? What have you been up to?
Been doing well. I've been running a lot. We'll leave it at that, but I've been doing a lot of running, which is fun. It's always a fun pastime for me. Exercise, all that good stuff.
Running away from people, like wife, or just something else?
No, the activity, the sport of running. Yeah. How about yourself?
Not running. Been trying to not chop my limbs off, not fall downstairs and stuff. Just being clumsy, really. And then obviously in the UK, we've had a storm, so I've been doing some swimming as well recently, which is not something I should joke about. Well, the Land Rover, to be fair, has been doing some swimming, but other than that, yeah, not a whole lot really. It's winter, which means it's kind of eat crap, watch terrible TV, and just get fat until spring. About it, really.
Yeah, we've been doing some pumpkin picking over here.
Oh, nice.
With the girls, so it's been fun.
Cool. You carved out those faces in them.
Tomorrow we're going to be doing that. Yeah.
You going the cutesy route, or you're going to put some horrific kind of scare yourself to death faces in?
I do the horrific thing, and the girls do the cutesy.
Just take a picture of my face and then print it on the front, and then just cut me out, and it should do the job just quite nicely. Yeah. Scare everybody to death. Anyway, enough from nightmare-inducing material to another set of nightmare-inducing material. I wanted to talk about streams and consumers at a most fundamental level, and there's some trade-offs that you have to make when we start talking about designing things properly with NATs. So I've often been fascinated what drives people to make architectural decisions around where the data comes from, so sourcing the data, and then where it goes either into let's just call it a funnel, really. I guess it's a FIFO funnel, and whether they choose for or whether they opt for a single stream or a single funnel, or whether they split it up at the point of source, or do they do some processing and so on and so forth. So at a most high level, and we think, I don't know, we need to probably think of an idea for this, and this isn't pre-planned, so maybe something like pulling in air quality measurements into a stream from different coordinates. So something we can discriminate on the original source of data, but maybe the format of the data is in the same style. So maybe we can encode it into something that looks similar for the stream, but the discriminatory aspect of it, where the data is coming from, is important. But what we might want to do is just sync it as quickly as possible. So air quality data coming in from sensors as and when we pull it in, and then we can do something downstream with it. And then I guess from your experience, is that a reasonable approach to begin with? Can we put it into one stream? What's a trade-off cost of then putting it into multiple streams and multiple consumers? So I guess, is that kind of design approach suitable for this conversation if we take the air quality thing, or do we need something else?
I think it's good, and we can talk about it in different contexts, meaning the small scale, or let's say a fairly co-located set of air quality metrics. Let's say your own home. You have a basement, you have different rooms, you have, because depending on your air quality within your home, or if you have different fumes coming up from the ground, that happens in a lot of the homes actually around my area of living. There's argon. So we actually have a device that monitors the levels of argon, and it changes all throughout the year, for example. So anyway, that's side tangent, but I think we can talk about it sort of in a co-located space, and then we can also maybe talk about it of saying there's air quality metrics maybe across a broader geographic region or something, for example.
Oh, you've made this so much more fun. Okay, so that's really
because it depends, of course, as it always does.
Depends. always. It wouldn't be IT, or can we say OT these days as well? It wouldn't be IT and OT if it didn't depend. Anyway, so I love the idea though. So if we have then the model unit of a dwelling, a house or an apartment, whatever. So we've got some rooms that belong to a property. So we could have, bedroom 1, bedroom 2, lounge, kitchen, basement, whatever. And then the lovely thing is there are going to be a number of dwellings on a street or on a block, and then so many on an area. I like this is where this is going. And we could have so many in is it borough? Does that work for the US?
Yeah.
Borough and a county?
Mm-hmm.
Yeah, because I guess our
That's fine.
counties are your boroughs from a size perspective.
Like
your
then you're
counties
talking
are
about
size of
then
the
you
UK.
talk about New York, and then you have different boroughs of New York. So that's
Uh-huh.
I think you can use whatever term
Slice
you
and
want.
dice. Yeah, that works. But I guess what I'm trying to do is trying to build a mental image for a complex, simple data, but arranged in a complex, not even complex, arranged hierarchically is maybe what I'm going for here, that we can use as a model. So keep things simple then. I guess mode 1 would be gathering data from a single dwelling. So let's say 4 rooms, what have you. And then we can pull, so in this model setting then, each room's data would be, and you know what, let's flip this around into a Q&A. What would you do? Would you have each room's data as a separate subject, or same subject and bury the data in the payload or in the header?
That's a good question. Yeah, so definitely expose that bit of data in the subject, so you can discriminate against on the and I think it's a key thing to think about too, which is the degree of subscription filtering on the consumer side is all based on the subject of the stream that you're consuming from. So the first thing that people should think about is to say, for the downstream, like when you're modeling your subject hierarchy, it's really frankly for the consumption side. Like you can publish messages on a subject, but interested subscribers should be able to differentiate based on subjects and the wildcards and things of that nature. So it doesn't change with streams and consumers. You publish into a stream given this subject hierarchy. So I could say like dwelling 1 or whatever dot, and then maybe the room ID, whatever that might be. And then that would be a minimal way to differentiate not only the dwelling, that could be different across, of course, every street or across the street. And then relative to that, the particular room or level of your house that you're actually collecting these air quality metrics from.
Yeah. So going back to the subject, I guess the kind of naming pattern, hierarchy, what have you. So I guess the thing with NATs is the subject namespace is kind of arbitrary. So we could have a postcode, we could have just a set of, whatever, UUID or something, or a GUID, which represents a dwelling, and then a number of, sub tokens for each room. So it might be a GUID to represent an account, a user's account, or whatever, the registered dwelling address for the person's account, and then these kind of dot, so the period, I don't know, kitchen or something for the room where the reading is coming from. So then if we have that at our most fundamental unit of discrimination, then comes a challenge of, so let's say we have 50 homes scattered across the country. What do you do then in terms of your stream discrimination? Would you just have one big stream for the entire business, providing that stream is going to be spread across your server pool, your available resources? Or would you divide that out, I don't know, maybe for admin reasons, maybe size, you've got like a dense dwelling area versus, a light, and in a lightly spread dwelling area. This one fascinates me because you've only got a certain amount of resources to go at, and irrelevant how you slice and dice that up, it might be easy to think about and easier to grok. But from a machine point of view, where does it matter and why does it matter?
Yeah. So a couple questions that have to be answered, at least how I think about this, is to say, if we have the ability to push a stream and co-locate it with the source of the data where the collection actually exists. So in this context, that would mean there's a server, that exists somewhere, close to, like, let's say within a region, within a what have you. And its job is basically to be the ingest for all of the data within that particular region. And whatever region means, it doesn't mean, data center region or anything. It could mean, neighborhood, right? So whatever the granularity that we can think of, or that is available to actually make a stream accessible to, that's going to obviously reduce latency of collection because it's going to be closer to the source of the data. It's going to provide availability, most likely because it's not in a, it's not across the country that, the publishers have to actually send the data to collect. And frankly, and this is another factor that we can kind of get into, but a stream in NATS provides a total ordering on ingest. So once you can have obviously many publishers, whichever message gets in first is going to be, stored first. But from a consumption side, it's always going to observe the same order of, let's say, the air quality metrics. And depending on, and this is why I always go back to say, well, what are your access patterns for this data? Like what degree of ordering do you need or not need? Depending on, let's say, for a particular dwelling, for a particular room, it probably matters. For example, if you're in a room, you want to see the air quality, metrics over time relative to that room in order, because maybe, who knows, you have cats or dogs that come in and your air quality is shot, at nighttime or something, and you realize you're actually sleeping with dogs on your face and it's actually terrible for your health and, all those kind of things. So having out of order events or metrics is not helpful. So you want to maintain ordering of that. But then you could say, well, between two dwellings, maybe you don't need, depending on how you intend to use the data, maybe you don't need, ordering with respect to both of those. And frankly, they're two, concurrent entities in the world. So you're not really going to get that anyway. They're inherently concurrent. So it's sort of like you can break down the stream. You can certainly have a single stream that literally everything is just being funneled into. You have the discrimination factor at the subject level, so you can still consume it, individually based on the subject hierarchy that you've designed. But the choice of one stream versus many streams really kind of comes down to how co-located do you want those streams to be, and also, frankly, the rate of ingest. I mean, when you have a single thing just ingesting, and writing to disk, you can't obviously exceed past the throughput of your disk that you have. So it might be necessary from a purely physical, technical perspective that you actually have to break up the ingestion rate, and therefore you would have multiple streams. But the benefit is that you're still addressing the data by the subject on the consumption side. So you can have n number of streams, and you can still say, I define a consumer. I'm still interested, in these particular subjects relative to the stream that could be broken down by region, again, whatever the granularity is. And I can still filter with respect to the subjects, and I can still get down to a dwelling level, a zip code, what have you. So I'll pause there because I've been rambling a lot.
But you've not been rambling. You've been going through some really useful stuff. And the problem is there's a lot of useful stuff to unpack. Check me out using the term unpack, I think, in the right way for once. So if we think about then single dwelling and multi-room, and what I might want to do is I might want to do a side-by-side comparison of the air quality in a set of rooms. And I don't know, maybe I've been like, hacking my home and I've got different plants in the room to, provide more oxygen, whatever. I've got a friend who does this and he's kind of proper into it. And I might want to do at midnight, my, quality of this plant provided a better atmosphere than, whatever, this other plant. So then if we have an order is maintained in a stream, I should be able to, in theory, read those messages in order and load them onto, a graph. And then that graph then should be inherently ordered, in theory. But then I think, I guess, going back to what you were saying earlier on, then once your unit of discrimination changes, and maybe it's actually your next door neighbour's dwelling, they're going to be in a different place in the stream as well. So we're going to have to, and this is, I think, really why I wanted to cover this off, because this gets really interesting. So within the range of, so let's say a particular GUID which represents a dwelling, and then some tokens, which might represent a room, they're inherently ordered. But then I guess the neighbours, assuming single stream, the neighbours' data is also inherently ordered, just at a different place in the stream. It's going to be interleaved in the various messages, which means in real world, if we do a side-by-side comparison, there's going to be loading time differences. Just to go through and talk through the logic of this thing. But then let's say if we change the parameters of what we're doing here. So imagine now we're running a SaaS, and we've got a load balancer in front of a bunch of ingestion mechanisms for the data. The data is just flying into the front door of a system, and our ability to store the stream where it's coming, where the data is coming in from, doesn't exist. So let's say we're creating a massive influx of data. How do we then begin to structure one of those systems? So let's say we go from the confines of a self-contained system on a dwelling, which is going to do this, so we can store that stream locally. But then now we're going to push it over the internet, over to a SaaS that's quite dumb. There's just one big ingestion funnel. Now then, I guess at this point, how can we discriminate the data and push it to where it needs to be?
Right. So I guess on the publisher side, I mean, you're still addressing a message by subject, and that's sort of one of the beauties of NATs in general, where on the publisher side, all you care about is what subject you're publishing to, not concretely the stream behind the scenes that it's actually being stored in. And that's one of those things where there's different options where you can say, we have this notion, we're not going to get into too much in the weeds here, but you have this notion of like subject mapping and stream sourcing and all this kind of stuff that gives you this ability to say, no matter, what subject a publisher is publishing on, it'll be routed to the correct underlying stream whose job is to basically store that data. And so there's that choice when creating streams to say, how much do I want to break this down? And just to kind of maybe boost up the example a bit more as well, again, thinking of the consumption side, you might say, well, if we have air quality, we have a timestamp that's just inherent because, you're measuring over time. So there's the ordering as it is ingested within a stream. And then you have maybe a timestamp associated with that as well. That's already, on stream ingest, it gives you a timestamp, but that's really, storage time when the server gets it, not necessarily the time that the data was actually collected at the source. So you could have this additional information in there. And then depending on your use case for consumption, let's say, you're the Environmental Protection Agency, the EPA in the US, and you want to do analysis on the various, air quality within particular regions or neighborhoods or something like that. And that's where you could say there might be a stream that has all the data ordering, again, with respect to maybe the time, maybe, with respect to the dwellings that you've collected within those particular areas. And you could create a consumer that would basically be, filtering on that particular area, and you could be doing analysis on that particular data. So there's the transparency on the publisher side to say, I can have any number of streams as long as I publish the subject and that subject is mapped to those streams under the hood. Publishers don't have to care, and you can change that topology over time as well, meaning the set of streams and your NATS topology if you choose to. And then similarly on the consumption side, this is a little bit, we can get into this because there's a couple of nuances with the consumer end of things, because you do have to know which physical stream you're consuming from. but we can talk about that as well. But hopefully that was a semi decent answer to your question.
Yeah, I think I was going to backtrack and validate. So from a publishing point of view, obviously we're publishing to a subject. So what we're going to have is a sensor from a dwelling that's going to have access, say, to a NAT system. It should only, in theory, be authorized to publish to, say, a GUID dot something or other pattern anyway from a subject point of view, which is then the discriminator for the dwelling discriminator, and then everything else is permitted after that, which kind of gives us like a sort key, I guess, over the data, so we can go over the index and then pull information back from using from the GUID as a sort key. And then using mapping, we could probably do something different there as well. Maybe we can tokenize and then sort it, based on the second token, whether that's by room or something like that. But then I love your kind of viewing through the lens of the access pattern or the consumption pattern. So that one's quite interesting. So I want to just hang on two different things right now. So the first one being something like the EPA or an environmental agency wants to do some analysis. And it can do this in one of two ways. Either access the streams by GUID. So maybe, he does like a spatial index search on another database and says, hey, give me some sensor data from this area, from these coordinates. And then it says, oh, hey, this stream is, this stream has got some data in this area. And it could go and basically add a consumer and then pull data, pull data back. Or, and this is the second part to this, would the more sensible thing to be doing as you consume the data as part of your access pattern, maybe do like a summary of the data and then post it to, like a global view, and then have that data ready to go as part of your application. So how would you go around architecting and building that out, that whole pattern?
Yeah, so I think probably for people, I would say maybe it's akin to something like a view or a materialized view in a database, where you have this option, and we touched on the stream sourcing before, which sort of can skirt around this problem that I mentioned just a second ago of like, you have to know, which consumer or which stream a consumer would get bound to. And the way that you can do that is essentially say, I have these origin, we have different terms internally, and we have to come up with saying, well, how do you differentiate a stream? Well, sometimes we call them like source streams or origin streams, of where there's actually the origin of the message ingest. And a pattern that has emerged over time, and something that has been baked in to NATs for some time, is this notion of sourcing streams. And its job is really to say, I'm going to multiplex, all of the data from all of these source streams, these origin streams, no matter where they are, and I'm going to funnel it all into one stream. So you're decoupling. And what's interesting about this is that this is an asynchronous process. And so you still have the ability to have those origin streams online, highly available, collecting data at will at the rates that is necessary for those streams. And then you have this sourcing stream, which is able to say, I'm going to asynchronously, it effectively acts as a consumer, and a consumer across all of those streams, sourcing all the data into itself. And even more interestingly is that you can have completely separate retention policies and all this kind of stuff, and setups, and the underlying storage layer, compute layer, what have you. Obviously, if you're sourcing data from, let's say, tens, hundreds, thousands of streams or something, you're probably going to need a fairly beefy amount of disk space, for instance, of this sourcing stream. But you have that choice to say the origin streams can be very lightweight, very simple. They'll be highly available themselves, and when they're connected, the sourcing stream will be able to basically ingest that data, and then you can basically you can create consumers that are going to be bound to that stream that's sourcing everything. And then you have the full ability, all the subjects in there. You can still apply wildcards With 210, we added the ability to define multiple filters now, which is really nice. That can be disjoint. And so that would be an option. And you can still have the choice of saying, this sourcing stream might be massive, but I want to have a short-lived retention for it. Once I consume a subset of, this particular region, I do my analysis, I act everything, all that data gets deleted. You could retain, the original source data if you want to. You could have another workflow of saying, I have two consumers, one for the real-time analytics and one for, persisting out to stable, object storage or something external for archiving purposes or something like that. So that's how I would probably approach the problem, and knowing, the appropriate retentions and things like that, and the end-to-end latency, depending on, how real time you need this processing. But that's how I would probably approach it, rather than saying I have this one single stream that everything basically has to deluge into synchronously. And so that would be my approach.
Yeah. And unfortunately, with all this conversation, it kind of hangs on the it depends part, I think, to a large extent. So I think half the puzzle is figuring out where your data is. So that the system that surrounds NATs at this point, it might need to track things like your GUID, your dwelling ID, and then figure out, what stream that's bound to. So then obviously you can attach, consumers or source from that particular stream, as like part of the problem initially. But that's not exactly difficult. I mean, once you set an account up, you might just loosely track that stream data anyway, and then being able to source that somewhere else and place that somewhere else is interesting. And there's other aspects of this conversation which we're clearly steering away from right now, which is like raft and network traffic and replication and all this kind of thing, which I'm just going to put a pin in for now. But then the opposite approach would be individual streams. So maybe if we have a it depends clause where we size a stream for the hardware it's running on and the system it's running on, as opposed to the administrative approach, which is maybe you have a stream for every dwelling that you have. Because once you go and you say, well, hey, let's have an R3 or 3 replicas of that data, immediately the load on the system increases with each and every stream. So if I kind of reiterate this, the approach in my mind's eye at this point would be to think, okay, we've got a bunch of servers and they're capable of, X, Y, and Z throughput or IO. We know what our IO limits are. In which case then I'd look at, well, what do I need to have, say, an R3 or a 3 replica of a stream, and then I'll attach so many dwellings, I don't know, like 1,000 dwellings maybe to a stream, and then have that replicate 3 times, and then once that one's full, create a new one, and so on and so forth. I mean, would that be fairly reasonable? And we can get into the dimensionality of why in a moment.
Yeah, I think so. I mean, like anything, we always should start with the simplest setup. So if you can, depending on your throughput, depending on your reachability, let's call that the distance between where the origin, the publisher is, to where the stream actually lives, and if that's reliable and the latency sufficient, then great. But yeah, I mean, if we can get by with a single stream that can handle everything, that's the simplest thing to operate. It's, as you said, there's less infrastructure requirements for that. And then we really have to then decide, is that sufficient? Does that, meet our requirements and whatnot? Or do we physically have to break down and add more streams? And I think there's other, and just to contrast this for folks who have experience with other sort of like log-based, systems, NATS is different in that we have a single stream, which is totally ordered on ingest in storage, versus other systems that are more like topic and partition based. And you have this like logical concept of a topic, but under the hood, it's actually broken up into like multiple partitions. And the partition in those systems are actually the unit of total order and unit of replication. So a publisher in that context would say, I am publishing to a topic, but it's really just being, routed to a partition. It could be round robin, it could be pinned based on some key or something like that. And those partitions are the things that are actually totally ordered and replicated. And then on the consumption side, you kind of have the same problem of saying, well, which partition do I actually have this origin data from? And there's also the downside or the lack of capability of associating a particular subject. You don't have, this ability to filter based on this subject hierarchy in those types of systems. So you have less control of really knowing, like, where did the data land? Which partition should I actually consume from, for instance? I can't address it by a subject that's known. So NATs and other systems like that are sort of topic partition based are very different. And it's frankly, in my opinion, I'm biased, but it's my opinion that I think that the NATS model saying we can address messages by subject. You can have a heterogeneous number, even though we talked about, air quality metric is probably one, message type. You can have heterogeneous types of data in a single stream, and you can discriminate them, again, based on subject. So you might have one type of air quality metric about this thing. There might be a different, measurement that you made for this other thing, depending on what air quality means to you. So yeah, going back, that was a slight tangent, but going back to what you're saying, I think if the load can be handled with one stream, just use that, because that's a simpler approach. It's less overhead, less infrastructure costs, things like that.
Yeah, I tend to try and view the world through the most simplest lens possible. And also knowing that you can start there and not necessarily trip yourself up. So even if you go on a large stream and you attach so many dwellings to that, or so many units of discrimination, I guess, and I'll tie that back to subjects in a moment, it seems to make a lot more sense in my head. And we can talk about, raft and things in a moment. But like all these things, place lots of ideas into my head. In fact, I think we probably need to actually just touch on the infrastructure and raft a little bit. But just before we do that, I think you made a really good point earlier on, and obviously comparing it to a topic and partition based system, where a subject is the kind of it's like the naming of our. I guess it's like a naming of a payload, that there's no number on the end. We don't have to monotonically increase that. But let's say if we have a subject to foo and we map subject foo to a stream, whatever we send to foo as a subject name, and then whatever's in the payload, then we'll go into that stream order. But if we do something like foo.1, it's not like, unless we do any mappings, and our stream says, actually, I've got now foo.wildcard, so like a right chevron or something. It's going to grab foo.1, foo.10, foo.18, foo.42, and then put it in the same stream. It's not like it magically goes off somewhere else and we've got to figure that stuff out later on, or it's not, it's not going to break the ordering either. So the subject names really give us a means of sorting data once it's in the NAT system and then putting the data back out through the consumer. But it's not like intrinsically that data is going into a different place unless we tell it to do so in the configuration. I think the subject kind of naming approach gives us a bit of a superpower in that regard. And it allows us to think about the world in a much more simple way. I probably hammed that up pretty badly, but I've got this like image in my head right now of, like a magic sorting hat.
Yeah, and I found it's been useful to describe the job of a stream. So people who have come to NATs and they know NATs, stateless messaging, standard pub sub, request reply, all that kind of stuff. You need to have these subscribers connected and online at the time a message is published to actually have it be delivered to that client, right? So NATS out of the box decouples your space element, the location transparency aspect of it, people know and love. When streams and consumers and KV and all this kind of stuff, all the durability, the persistence component of this was introduced, now you're decoupling time as well, because, and the job of the stream is literally an internal subscriber in the server who says, I'm subscribed to these subjects that you've configured me to be like aware of or subscribe to. And my job is literally to persist this on your behalf. That's it. I mean, in its most basic form. So when you configure a stream, you're basically just setting up an internal subscriber on the server who knows how to write this out to an efficient format in disk.
Or memory.
Yeah.
That's always worth mentioning.
Yes. Yep. Yep.
You described that so well. Sorry.
But it's just like, it's a simple thing to think about. Then you're like, okay, so great. So I know that, this server or these set of servers, if it's, replicated, there's a leader, and the leader's job is to basically know, all right, I'm subscribed to the subject. Nats, because of its location transparency, magically routes things to the interested subscribers, and it stores it to disk. It's, sends it off to its other replicas. They store it. You get your ACK, chain, and then you're good to go. And that's completely decoupled from the consumption side, naturally. And it's like, now that it's written out, the consumer, there's a whole consumer, which is a server-side construct as well, to say, oh, this consumer is also bound, to this stream and subject. I have active clients or active, client-side subscribers connected right now. Now I know as a consumer, I have to start, delivering the messages. And so you have stream and consumer server side, you have publisher and subscribers client side. So you have sort of this nice kind of synergy there. And you have a lot of flexibility as a result. And like you said, it's like you're decoupling the subject hierarchy from the underlying storage medium or the number of, physical streams that you're actually laying out to take in all of these published messages. But that's an independent choice, and that really again comes down to can a single stream that's replicated take the throughput? Is there some high availability need, or are things so geographically distributed that it actually makes sense to have streams that are co-located with those areas, and then the sourcing stream approach is more pragmatic. But yeah, you made a really good point there that it's like, it's something that, again, with other systems that are, persisting messages and logs and stuff like that, you kind of have to know the topic name explicitly that you're like publishing to. So the way that you organize and think about structuring your things is different. And so I think the subject-based addressing that Nats brings in his first class is really powerful in this, and it gives you a lot more flexibility and freedom to make different design choices and evolve it over time.
As always, you kind of lead me beautifully into more exploration. So I think that there's a couple of nuanced points I want to raise first. That the payload of the message is just a bunch of bytes. So even though we've got a schema registry and all this other stuff, you can put, you could have messages published to foo, and you could have two different payloads. I mean, that would probably be terrible for downstream processing and would involve reflection and all sorts of horrendous things. But it's possible. You're not going to break the system, So I think with a, topic and petition-based system, the reality of that is most systems will have the same, schema for the data, whatever, encoding type that you've got it with the same structure. With NATS, you've got absolute flexibility over that. You don't need to, structure it around the encoding type or even design streams just to house one form of data or one type of data. So that's interesting. I kind of forget that sometimes. I think, oh yeah, I'm so used to the flexibility of this that we don't have any of these this kind of like weird constraints. But the kind of, I guess, the aftermath of what you just said there, that sounded like horrendous. Not aftermath. The thing that I want to talk about is I just want to walk through the journey from PubSub, so this whole location transparency thing, to then making it or decoupling it from time. So in the PubSub model, and just to reiterate really what you've said, is you'll have a publisher and a subscriber. These are client-side functions that attach to Nats as a broker, and then Nats will, if it receives a message from a publisher, and there's a downstream subscriber that's registered interest into the subject, it will basically fan out and forward the message. Now, this is where some terminology kind of trips people up, or the way that you think through this stuff. And I see this a lot on kind of customer calls. When we then want to decouple it from time, what happens is, like you say earlier on, a stream is an internal subscriber. It will subscribe to, say, Foo, and it will place it, whatever, onto disk, onto my Insta stories of some form, and it will retain that. It is a durable function. Now, what you don't do is you don't subscribe to the stream. You consume from the stream. And this is where we see this a lot. So the idea is, on the client side, you will attach to a consumer, but like you said earlier on, the consumer is the server-side function. We create the consumer and attach it to the stream, and then we literally talk to it from the client code. We go, hey, consumer, pop us a message off, please. And then if you set up explicit acknowledge, you acknowledge that thing, then it basically pushes forward in effect a sequence number. And then we can then go and get the next one and acknowledge that, and so on and so forth. And then the servers actually then take care of, let's say if we have a stream with a replica set of 3, and then we have, and this is I wanted to get into the nitty gritty, then we have some consumers configured on the server. How do we then view this from a resiliency point of view? So the consumers themselves, because they're server-side functions, are they replicated in the same way as a stream?
That's great question. So consumer, as we said, is a server-side construct, and there's a reason for that. Very important reason for that, because its job is to keep track of messages that of the target stream that a client subscriber is actually interested in. So again, when you define a consumer, you say, point to the stream. By default, let's say we don't apply any filter. We just say, I just want all the messages in the stream. And we can get into, the models of consumption in a second, meaning on the client side. But its job is literally to say, let's say you start from the beginning of the stream and you're just consuming all the way to the end, and on, right? It has all this internal state to keep track of which messages have I delivered, which messages are in flight, where basically can I, once I've successfully delivered a message, I can change my offset to say, all right, everything beyond, this point of the stream, or prior to this point of the stream, I've already acknowledged and delivered. So, I update my internal state of like the last sequence that I've delivered, for instance. But then you're going to have things where you're delivering it, that's in flight, it hasn't been acked yet. You have to set a timer to say, how long should I wait before I try to redeliver it? Maybe maybe it got dropped on the network or something, and I have this guarantee, this at least once guarantee of delivery by default with a consumer. And so it's just going to redeliver until the client says otherwise, basically. Assuming there's still client interest, it's going to just try to redeliver because it's like, that's my guarantee I'm providing you. So it has all this internal state of basically, which messages have been delivered, which have been in flight, all this kind of stuff. So because that state, that also has to get replicated, right? So you can have the choice of saying, I do have an R3 consumer, and it actually follows the model of the stream that it's bound to by default. So when you create a stream, if it's an R3 stream, you create a consumer. If you don't change the replication factor, it's actually going to inherit the replication factor of the stream that it's bound to. So effectively the state tracks the replicas, the servers that the stream is on as well. So they're co-located, which is also important. It's not like a disjoint type of thing. You can opt for saying, I only want a single replica consumer. There's use cases for that. Like if it's not going to be a long-lived, durable consumer, and you're just basically doing sort of for the lifetime of a process or like a one-off consumption, you don't need, that extra overhead of replication, all that kind of stuff. So you have those options. But yeah, so you have the server-side construct of a consumer. It has to track the state. You have choice of replication. It's going to match the replication factor of a stream by default that it's bound to. And then we'll pause there, and we can then talk about, on the client side, when you actually are active subscribers and having these messages being delivered to you, what are some options there to, do different things?
It's like you're reading my mind at this point. Yeah, there's just a lovely natural progression about this whole thing. So one of the stupid questions I'm dying to raise, the data, once it's been synced from whatever source it's coming in from, is probably the most important part. So let's say we have air quality coming in from a dwelling, and we want to make sure that thing persists through time for whatever posterity, some nonsense, or whatever, we're saving it for aliens and they can observe the decline of man, something like that. Sorry, I'll edit this out. I think somebody's mowing the lawn. Okay, that's crazy. Just a marker, 48 minutes, give or take. The lawnmower started. Okay, whatever. Yeah, so as we look at preserving the data, we might have data being synced, and that might be air quality. We might have an R3 replica over that, so we make sure the stream is in 3 different places, and one node goes down and disks blow up, whatever, we've got the data. But then you get into this concept of, well, because I've got an R3 on the stream, do I really need an R3 on the consumer, especially if the consumer and the activity is fairly ephemeral? So maybe I've got like a web UI, I want to see a graph. Is it normal then to basically create a consumer for the purposes of rendering a graph and then kill it?
Yep, absolutely. So that's where the use case of like, am I doing like a one-shot read of the data for the purpose of rendering something? As an alternative, you could have sort of a graph that might be like rendered in like in the browser, in a live format, and you need to like read it, and then you just kind of like want to update the graph as the data comes in. That could still be an ephemeral, because you could click refresh and that ephemeral consumer goes away, and you just redo it again, right? So that pattern definitely is, or that use case is definitely very much ideal for sort of this one-shot R1 consumer. We actually have as part of the client API, there's actually, for those who have maybe seen this or may not be aware of it, we have this particular convenience option when you define a consumer called ordered consumer. And it's really just kind of a bunch of default configuration options that make it so that it's an R1, no acknowledgement. It handles, if there are drop messages, it actually retries and resets itself internally. You don't have to manage that. It minimizes the amount of state on the server. And it basically puts a little bit more work on the client itself, but that's all again abstracted away in your client library, the Nats client library. So, but there's that particular use case that says, I want to consume from the stream, either from the beginning or some offset or from some timestamp or something. Just deliver it as fast as humanly possible or as machine possible from the source. And I know that my client subscriber is going to be able to handle that, because that's one of those things of saying, depending on the work you're trying to do with the data, like if you're taking your good old time of processing this data or handling these air quality metrics and you're spinning your wheels, the server's not going to be happy about that, and they're going to be like, you're a slow consumer of this data, so I'm going to disconnect you. So that's a whole other thing that we can kind of maybe touch on. But yeah, so for that particular use case though, you're just saying, give me all the data, a quick read, I'm going to render it out, handle it very quickly. And that's great. But then you have the sort of like the other extreme, which is you have some like long running kind of maybe processes that you want to resume over time. So you want to be able to handle the case of, I get disconnected, I need to resume my work that I was previously doing based on the last message that was delivered to me, and I don't want to have to like replay everything, and that's where you want a durable consumer, that you actually maintain the life cycle of that consumer. more explicitly, and you want the replication factor, so that's not going to get lost in the case that the server with the single replicas actually goes offline. So
Yeah, I think that's a pair of really nice patterns for, or certainly that style of consumption. Both styles of consumption, get my words right. They're really nice. So if we now talk about then and move on to client-side logic for interacting with consumers. So I think you've got the fairly obvious one where you've got push-pull. Obviously, we can either get consumers to push messages at clients, or we can get the client to pull messages down. And then we've also got whether we acknowledge. So once we have the message, maybe we do something with it and we acknowledge and say, okay, give me the next one. And then we've also got things like in progress notifications as well. So for like, let's say if you're running like a worker queue and you pull a message down or you get pushed a message, you might do something on that and sit on that message whilst you're processing something else. And then you can, I think within a 30-second time window, send an in progress to stop redelivery attempts as well. But then also you've got NACs, or negative acknowledgements. And we've got all these different and weird and wonderful things. And to your point earlier on, you can have a consumer that with no acts, so you can literally just pull as fast as you can and just pull that data down. There's so many, I think nerd knobs is probably the only way I can describe it. And they've all got different, they've all got different purposes and rhyme and reason between them. So have you got any kind of easy ways or any rules of thumb for these kind of, different controls on the consumer's client side?
indeed. So one one thing to note, and those who have been following along with some of the new client work with the new Jetstream client API. For those who have been following along with that, you may have noticed that there's actually no distinction anymore of a push versus pull consumer. Internally, it actually is all pull based now, and there's a reason for that. So if you think, going back to what you were saying, David, the whole, as the name suggests, the whole notion of a push consumer is that, again, this is a server-side contract, and the client is effectively creating an inbox subscription, so a random subject that you can configure this as well to be an explicit name if you want, but it's basically a subscription, and then that is the subscription and the subject that the consumer is going to actually be delivering and pushing messages onto, just like you would have if you had a standard pub sub set up. I'm subscribed to this subject and this is the publisher. It's just it's the server is going to be sending it right down to that subject as fast as possible, as fast as the publish side is basically sending the data in. So what happens in that situation, depending on how long your processing time is on the client, that can overwhelm applications. So because again, you have to basically handle how much data is coming at you. There's a bit of control on consumer configuration where you can say max act pending, which basically says like how many messages can I push down in flight, for example, to you. So I'm not, I'm filling your buffer basically with messages to process, and you better process them within this amount of time. And that whole push-based model, even though it sounded nice in theory, I think actually confused quite a few people, because they're just like, I don't, there's this whole notion of like, and I'm not gonna, you're the expert with, networking and whatnot but I was going to mention the term flow control, and client applications are like, oh, I have to deal with flow. What is that? Flow control? Like my application is being overloaded effectively with the amount of messages that are being sent to me. So the other consumer option is a pull-based consumer. And this is basically saying, as a client, I get to choose on a per request basis what's my batch size of messages. And people hear batch and they're like, oh, it's not real time anymore. It's not fast. It's slow, blah, 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 right? And the reality is that all this work has gone into, especially with the new client APIs for Jetstream, they're very intelligent in actually being able to interleave pull requests on the client side, So it's basically minimizing the amount of latency between every subsequent batch that is being pulled from that consumer. And so all the work has been done to, and it's continuing to be optimized further so that it's effectively on par, if not in some cases faster than a push consumer model. And so the benefit of this is that as a client developer, a client-side developer, I don't now have to worry about being overwhelmed. There's, the client, because these are being pulled on demand as I'm able to kind of keep up with them. I have no issue with that anymore. So as long as basically if acts are enabled and as long as you're acting within that time frame or setting the in progress state as you called out, I'm not going to run into these issues anymore, which is really nice. And it also removes that additional decision factor to say, should I do push or pull? It's like, well, no, we just have this notion. And again, in the new Jetstream client API, there's just consumer. There is no push versus pull anymore. It's just consumer. So it simplifies sort of the decision making. We're not giving up on performance. And again, all the clients are continually being optimized further and further. So I'll pause right there if you have any comment, and then we can kind of actually get into the subscription, the client subscriptions options now that we've, distinguished the push versus pull consumer.
Yeah. Obviously, it was me being loaded regarding with the push and pull. I mean, it's really just to get the point across as well that we've actually simplified this down a lot, and being able to get batches as well is a lifesaver, because when we think about consuming data, I think a lot of people think about it in linear time, go grab something, do something, go grab something, do something. But obviously, if you go and grab 10 things and then you process a thing 10 times, actually over time, there's no real difference. And actually, it can be a little bit faster sometimes to go and make one network transaction and then make use of high-speed I/O locally to do the processing and then go and get, 5 things. So you lose the network overhead of fetching one at a time, pack a load of stuff together, because ultimately it's just a bigger packet. It's one TCP bunch of framing as well. You end up just, I think, essentially you kind of run faster from a batch point of view regardless, which is kind of nice. But yeah, going back to the last thing you then said around consuming, I think we could probably nicely round this topic up, or subject up. Terrible dad joke, I know.
Yeah. So then there's a question of, so we have a consumer, which is a server-side construct, and its job is to deliver messages to active subscribers connected to that consumer. And I know that it's like it's connected to the server, of course, but when you say create a consumer and I get let's say a handler to that consumer, which is like, a client-side reference to, it's like, okay, I have an active, instance client side. I'm expecting you to send me messages kind of thing. The question then comes up of, well, can I have more than one active client subscription iterator, client-side construct that is actually having messages being delivered to it, right? So in the simplest case, you can say, I have two applications, and let's say I want to both point to the same consumer, which implies that the consumer is now going to be delivering to both of those instances of your application. So there's a couple ways we can enumerate a couple options here. So the standard one is that you have a single client application instance. You're connected. You're getting all the messages in order delivered to you by that consumer. And then the natural second question comes up, which is, well, how do I make my application highly available? What happens then? People are running in Kubernetes, everyone's like, HA, all the things. So now you have let's say 3 instances of your application, or even just 2. And then people sometimes get surprised when they're like, okay, I spin up both my instances. They're both connected to NATs. They're both bound to this consumer. And now the consumer is going to be load balancing. It's going to be sending separate batches. So it's all still, from the same stream. They're not getting different copies or the same set, same copy of data, they're getting individual batches because now the server is assuming, okay, you're trying to actually parallelize the work, right? Parallelize the processing. And then people are like, well, what if I want to retain perfect order? Well, yeah, that's the question that often comes up, right?
It's a question of questions, isn't it? That's when it comes down to it depends on what are you trying to do.
Exactly. So again, the simplest thing is like you have n number of instances, and maybe a simple reference point for folks is like you hear about AWS Lambda as being this massive like fan out parallelism type of approach where it will basically scale up to parallelize all the things, right? And for some use cases, that's perfectly fine. Nats can handle that beautifully. You want to increase the number of workers that is basically just taking, messages off the stream via the consumer. The consumer will happily basically load balance across and deliver across any number of instances that you have connected. And so you can truly parallelize all of the processing of those messages. But then people are like, well, going back to the example we started with, which is like, what if I want to retain order via a dwelling, right? And we want to have, or a particular room within that dwelling. And that's where you get into this question of granularity of a consumer via a filter. So on the other extreme, you could say, I have this massive, stream that has all of the data, air quality data that spans the entire country, let's say, as an extreme case. But I really want to just get data for like a single dwelling or something. Well, you can, of course, create a consumer that you can filter on that particular subject. If you happen to know the UUID, the GUID of that dwelling, you could say, hey, consumer, I want to configure you, and I really only care about any of these air quality events that have occurred and that are bound to this particular subject. So you apply a subject filter, and then that consumer will basically only deliver the relevant data to that client application that's currently subscribed. And there you go. So that's the other extreme. And people are like, great, that satisfies that because like the number of the amount of data that it's on a per dwelling basis is going to be quite small, right? Relative to, all dwellings across the country, let's say. And then the natural question comes up of like, well, but what if I have like 10,000 dwellings or 100,000 dwellings or clearly more, depending on how large a country is. And then you're like, well, can I have 10,000, 100,000, millions of consumers? Does that work? Right? So I don't want to keep going into this rabbit hole, but this comes up all the time.
Planet are you on? Oh dear.
And it's an interesting question because then like what I typically come back to of saying, all right, so you want that degree of granularity for some reason, right? But then you're saying, can I have, 20,000 consumers, 100,000 million consumers? Are you going to have that many client applications that are going to be deployed? And the answer is inevitably no. Like nobody's running, 100,000, a million containers, let's say that I'm just being extreme here, but like you're not going to be having that many deployable units, right? That are all going to be that granular down to, let's say, dwelling data. And so we have to like go back a little bit and say, okay, well, so where's the middle ground? And the middle ground can be having a client application that can apply a wildcard at the level of granularity that is sufficient that your application can actually handle in order, let's say. And that's again, like, let's take that as a simplest case. So you could say, within my neighborhood, within my borough, whatever, given, hundreds or thousands of homes, given the rate of ingest of the data, and given my latency requirements of processing this data, let's say, I can create a wildcard on my subject hierarchy down to the token level that is relevant, depending on your subject hierarchy. And I create a consumer just for that. And you can have a single consumer focused on that as well. You can choose to, within your application, you know, to handle how you parallelize that internally within your application. There's still always the question of saying, well, how do I, make this HA? You can define this max act pending, and that has been sort of one thing that has been historically noted as being like, you probably should do this if you want to truly retain, perfect order. But then you can get, and I'll throw one other option out into here, because again, we're just talking about like, here's different options, and we don't want to complicate things, but something that was introduced in 210 was actually in the spirit of expanding the options for trying to maintain ordering, having the ability to say, can I have sort of these logical buckets, let's say? So I can still have one client application where I am like the deployable unit, right? You can create any number of, consumers at various granularities that you need to. But on the ingest side of the stream, and this is again introduced in 210, you have this ability to now say, I might have, let's say my ingest, I have 3, 5, 7 tokens, whatever, my subject hierarchy is. And I can choose to apply this concept of like logical partitioning. So as the message is stored in the stream, it's actually going to derive and append, let's say, an additional token on the end of that subject that is actually just like a bucket. It's like a partition number. And again, this is not a physical partition like we talked about with the other systems. This is a logical partition ID, let's say. And it's deterministic. So given the same input subject, it's going to, be placed in the same, it's going to derive the same partition ID. And then you have this ability to have one more level of granularity to say, I can still apply a wildcard at the level that I am interested in, but I also have this partition ID token that I can further distinguish my consumer or a set of consumers to be pinned to that partition ID with respect to my subject hierarchy. So to say this in another way, you can say I have my neighborhood, I have 100,000 homes or whatever. I have this little partition token at the end. I can apply a filter on my consumer to say XXX, like whatever my hierarchy is, star wherever the neighborhood or borough is, or excuse me, the name, and then any more granular tokens like dwelling ID and all that kind of stuff would be wildcards. And then, but I can have a concrete partition ID, right? And so now I am only getting the data with respect to that neighborhood, but only with that actually landed in that partition. So within your application now, you can have different consumers pinned to different partitions with respect to the granularity you've chosen, and you will get total order within those things. So you have this ability to sort of break this down further and further. We don't have, and people are going to be like, well, what about, again, HA application? We don't yet have this ability to define an exclusive consumer. So there is this is something that has been brought up, but it's this idea of that if you have two client instances of your client application, you can actually have one exclusive subscriber. And if, heart beating fails or whatever, it's going to flip over to this other one. We don't have that today, but that's something that has been sort of discussed of potentially going on the roadmap. But in essence, if you're able to break down the load to a granularity that is sufficient, you could still, achieve this max act pending type of thing, or you can still parallelize with respect to like a dwelling, depending on your unit of concurrency that is appropriate for you. So that was a lot of information, but I think it's
as always,
again, it depends.
My brain is kind of like firing on all cylinders right now, and I'm bustling with things. I mean, going back to the exclusive consumer thing, I mean, you could kind of emulate that in a way by having writing a locking mechanism in your client code. So try and get a lease on the consumer, and if you can't, then you can flip flop between them. So you could actually use NATs to build a distributed locking mechanism to be able to balance on the consumer if you wanted to do that.
It's a great point. Yeah.
And then regarding the partition kind of stuff. That's interesting. So you could effectively have an ordered petition for an entire dwelling with, the GUID, each of the rooms, and then a petition number. You could have a consumer then pull that ordered data in, which is really, really powerful. There's so much so much to think about, and so many moving parts. I did have one more thing, but my brain is completely backfired on me as you ran through the descriptions as well of the. I think actually what tripped me up was the kind of exclusive consumer stuff, and then with the petition information as well, which is really interesting. Oh, I know what it was. Sorry, I've kind of my brain's just elasticated, retracted, and yeah, I'm running out of words. So from a hierarchy point of view, if we then think about the high level view, which was we have this SaaS, we have a global SaaS, and we're pulling in information. We might have an Anycast network where we the sensors publish information, so they go to the nearest IP of whatever the ingest point, which gives us some kind of form of a locality, which also means we could actually pin the streams based on that as well. But the subject might be formed of like an ISO country identifier and then a region. And big countries, you might do north, south, east, west, whatever, divide by some coordinate system, and then it might be enough then to have a stream for that level of whatever tokenization. Then you can have your GUIDs, which might be a dwelling, and then the tokens, and then maybe even the petition right on the end, then to localize it to an ordered stream. And I think at that point we've just built a global service, a globally scalable service for pulling in our example the air quality thing. So I think it's a really rounded view. This is way more than I was hoping for, to be honest. From this episode, I was kind of chewing on this, thinking, really, we should dig into this. So this is cool. Anything else you want to add in? I know we could probably talk way more about the kind of intricacies and the whole problem of it depends, but I think hopefully what we've done here is we've shown through talking through some ideas how we can basically build a tree that is got massive potential scale. We've got ordered systems within the tree. We can talk about where to place either multiple consumers with multiple filters or have one consumer with multiple downstream applications. You might want this notion of this exclusive consumption, which you could build effectively as an abstraction with NATs anyway. We've got lots of cool things we can be doing. I'm just thinking about this whole model. I don't think there's anything more I can add or ask. I think you've covered it off really, really well.
Yeah, no, that was a great call out with the exclusive consumer, and it's funny. I even though we've helped customers actually build that type of solution that's not native to NATs, but being able to say, hey, I have a KV bucket, and like our patterns episode a while back, we talked about leasing. So that's right. You could have multiple instances deployed, and only one basically acquires a lock, and they can be rechecking. You can have a TTL, and whichever one is actually acquiring that lock at any given time is basically the active participant. So yeah, that was a brilliant call out. So you could definitely build that yourself today for sure.
The only last
very little effort.
Yeah, I think they say relatively little. It's kind of fun actually to do these things. I say fun. Maybe I'm just a bit of an idiot. I don't know. I like hard things. But I guess the last piece of the puzzle here is people then talk about backups. What do we do? So we've got the important data, the mission critical data for our system, and how do we deal with that? So I think there's two approaches maybe here. One is to source a backup stream and maybe put it into objects and then push the object off and then maybe recall that and do a restore if we need that. Or do we just back the streams up at the infrastructure level?
Yeah, that's a good point. There's your typical backup and restore mechanism that's sort of out of band. The CLI supports that, and that's kind of your typical, like you have a cron job or something or on demand need that you can do this every so often. But you're never going to, with this mechanism, it's never going to be, incremental in real time. And so the general recommendation, which is they're not mutually exclusive. You can have both options, obviously, but you could very simply have a mirror stream. And this is you can think of a mirror as being a little bit more constrained sourcing stream, but the whole purpose of it is that you can create a mirror, you can literally define that mirror, put it in a different on different servers, or even across. If you have a multi-geo NATS cluster, you can say create this mirror from this origin stream in this region and create a copy of it in this other region. And so you have like geographically separate, copies of things, and you can create many mirrors if you want to have a little bit more redundancy there. And then, you can either just retain those as copies, or you can, because again, they can have different retention policies. So you could say, I have this stream that's like my archival stream of this origin stream. The origin stream could be pruned over time, compacted over time, let's say, but your mirror stream that is literally just be, on slower disks, you could apply compression to that stream, which is again another feature that we have. And so you're basically retaining that over time, or you could have a consumer off the back of that to, actually put it up, and you could apply compression to that stream preferences, for example. So we usually recommend both options. Backup restore via the CLI is straightforward, but you're not going to get sort of this more. We usually recommend synchronization like you would if you were to create mirrors first and then have a process beyond that.
And is it a good idea to time bound streams? So maybe you do UTC based stream, from 00 could 00.000. Yeah. Do you do a UTC bound stream where maybe you actually retain the data per day, per calendar date, and then that allow you a unit of backup? So what you might do is you might mirror within the day, and then actually every day, the whole thing's compacted down and copied as an object, just in case the whole system, whatever, blows up. It's a terrible way to think, but it happens. Yeah, maybe good, maybe bad. I don't know, but just one of the thoughts. But yeah, this has been awesome. Some real great food for thought here. So I'm out of silly questions to ask, and I'm certainly out of loaded questions to ask. So as always, I'm in awe of your skill with this, Byron. So thanks as ever for humouring the dumb stuff.
No, this was a great topic, and hopefully, if anyone listening, watching has obviously more questions, follow-up questions, things like that, feel free, because we love to talk through this stuff and hear use cases or hear challenges people, and they're like, well, what pattern is appropriate? How would you deconstruct this problem? It's one of those things that NATS it truly is simple. However, as David, mentioned, there's a bunch of nerd knobs, and there's reasons for having those, but beginners, people coming into it, see this, this swath of configuration options, and they're like, do I need this? Is this necessary? So it can be overwhelming for sure for people who kind of dive into it and be like, I don't know if it's like you don't know what you don't know. And so do I need these options? And generally the default should be perfectly fine. If there's, questions about different things and like retention policies people get hung up on and the ACK modes and things like that, feel free to ask questions. Obviously there's the documentation, there's NATS by example, your typical set of resources to get a little bit more exposure to things. So, but definitely reach out if you have more questions about this.
Well, I've got another question. It's a think fast curveball. You ready for this?
Sure.
So the Dave airqualitysas.com platform, I'm going to add alerting. I want to know if a dog's sitting in my face and suffocating me at night, which is unlikely but likely with a beagle. I mean, you can open doors and gates and climb. So in terms of our hypothetical design, we might have country-based. So from a token point of view, we might have country, we might have region, dwelling ID, and then rooms. If I wanted to do real-time alerting on this, where would you insert that processing pipeline? I did say curveball.
Yeah. So, I mean, again, depending on your latency, you're suffocating. So you need to be pretty reactive.
My wife needs to wake up, or maybe she doesn't, depending on the insurance payout. I'm not sure.
Yeah, I mean, you would for sure, co-locate your application workload to where the origin stream is, have a consumer right off that. You're not, sourcing things, mirroring things, that's all asynchronous. It's retries and network partitions happen and all this kind of stuff. But if you have real-time alerting that you want to be co-located in the place you're, frankly needing to alert on behalf of, I would need to push down my workload. Let's say you had, I don't know, like a Raspberry Pi in your house, hypothetically, or a cluster. You could have a stream there, an extension of your Dave SaaS offering. I have a little extension here that's ingesting the stream locally, asynchronously replicating and sourcing up to, the cloud. But then I could have a little workload that is actually doing the analytics and the prediction of, or the alerting mechanism that might, send an SMS or what have you. So the ability to co-locate, the workload doing the thing, depending on how latency sensitive the thing is, that's one of the, again, other superpowers with NATs is that you can, push the servers down to, we had the whole topic of the various edges last time. And so that would be my approach if you have that option.
Interesting. All right. Yeah, I thought I'd just throw that one. That's always a fun one. Yeah. Cool stuff. Well, this should make for an awesome episode. So thank you, Byron. And I hope everybody's enjoyed listening to this. As Byron said, we've got some great sources for information, the documentation. We've got NATs by example. We've got other episodes of this podcast now as well and other YouTube recordings. If you like this, please hit subscribe, please hit like, and we'll catch you next time. Thank you for listening.